solving equations often means using factoring. There's a lot of factoring tools out there. One of our favorites is when you have an x squared and an x. You can just use simple factoring and then get your solutions quickly. The problem with the equation like this is not quadratic. Look at this. We've got a x to the fourth right there on the left and an x squared in the middle. So I have a quadratic term right here in the middle, but that's not where I want it. I want the quadratic on the left and the linear in the middle. Then I can solve it with easy factoring. To do factoring on this one, you would need the rational roots theorem, which you may have learned about, you may not. If you know what that is, you're probably groaning inside. It's a bit of a beast. But there is a way sometimes to factor these things because there is a quadratic pattern. And I'm going to explain what I mean by that, by this word quadratic pattern. See, factoring quadratics is usually pretty easy. And when something has a quadratic pattern, that means there is an easy way to factor it. We just have to think a little differently about part of this equation. I'm going to do the following. And this technique is called U substitution. And it comes up quite a bit, actually. Sometimes with equations like the one we have here, sometimes with exponential equations, sometimes with trigonometric equations. I'm going to do this. I'm going to say, let's let U equal pitchfork squared. Okay? And that means U squared equals pitchfork to the fourth. So now let's rewrite this equation with these substitutions. It's going to be U squared plus 24U minus 25 equals 0. Well, now take a look at this. This is a quadratic equation. We can solve this with our good old factoring techniques, where you just say, oh, this is, what do we got here? U plus 25 times U minus 1. See? Undo the factoring. Multiply this out. You'll see you get U squared plus 24U minus 25. And that means we can solve it. So for this one right here, we say, great, U minus 1 equals 0. That means U equals 1. And for this one on the left, we say, okay, U plus 25 equals 0. That means U equals negative 25. So you're about to write these into your answer box. Say, I'm done, I've solved it. But the problem is we don't want solutions for U. We want solutions for this crazy pitchfork variable right here. So now's the part where you have to undo the U substitution. So you say, okay, well, no problem. That means my pitchfork squared equals 1. And my pitchfork squared equals negative 25. And I chose this one in particular on purpose because we've got a problem with these solutions. If you notice, what do we get here with this guy? This one right here on the left in orange. If you try to take the square root of a negative, you get imaginary numbers. And notice that this says, find all the real solutions. So in this particular case, we don't care about imaginaries. This whole side here is going to be DNE because you get imaginary solutions. Now, there will be times when you want to keep those imaginary solutions. It'll say so in the problem, but this one only wants real ones. We square root this side. What do we get? Pitchfork equals, what's the square root of 1? A lot of you are thinking 1, but it's actually plus or minus. Don't forget, plus or minus, when you're the one doing a square root, creates that plus or minus. So our solutions here would be 1 and negative 1. Don't even say anything about the imaginary stuff, the stuff in orange over here. Pretend that didn't happen. The solutions are 1 and negative 1. Now, if you had ended up with a different problem, maybe you got only imaginaries, right? Everything's DNE. Well, just say DNE. Or maybe you have no imaginaries. You've got pitchfork squared equals 25 and pitchfork squared equals 1. Well, now you have more solutions. You have 1, negative 1, 5, negative 5. It kind of depends what you're dealing with. The important part that I want you to get is this idea of using U substitution when you see a quadratic pattern. In other words, whenever these powers are in a 2-to-1 ratio, or 4-to-2, or 6-to-3, or anything like that, you can turn this into a quadratic using U substitution.